Okay, this section is about matrix and linear system. Okay, matrix is this is system of equations. There are two equations with two variables, and each variable has coefficient and constant, and the equation has constant on the right side. Okay, the matrix is this. Matrix is write only the constants and the coefficients only. So write the coefficient of variables and the constant as it occurs. So okay, the coefficient of x is -1, coefficient y is 5, that is equal to 2. So make sure the system of equations has the same order. X term comes first and the y terms as a second term. Then the second equation must have the same order. X term comes first and then y term. Then write the coefficients only. For the second equation, the coefficients are 7 and -2 equals -6. Okay, for equal sign, you can use colon like this. I will use a vertical dotted line just to indicate equal sign. So the system of equation can be written as this, and then I will use a big bracket. Then this is the matrix. And this matrix is called augmented matrix. And the second matrix is only the coefficient of x and y. The constant is not included in this. Then this is called the coefficient matrix. Coefficient, because we are writing only the coefficients. Okay, then each matrix has the dimension, the size. The order of the matrix is always the number of rows by the number of columns. That is the order of matrix. So in this case, this augmented matrix, the order is, there are 2 rows. So this will be 2 by, there are 3 columns, 1, 2, 3. So 2 by 3. This is the size, dimension, or the order of the matrix. How about the coefficient matrix? There are 2 rows, 2 columns. So the dimension is 2 by 2. Okay, then let's try the second example here. Okay, this system of equations has 3 variables, 3 equations with 3 variables. So the augmented matrix is, let me write all the coefficients including the constants. So 3, the first row represents the first equation. So 3, +2, +2, you don't have to write plus, just 2. And the coefficient of z is -1. And column represents equation 1. Okay, the second row is the coefficients of the second equation. So x equals 1. There's no y term. So just put 0. And the coefficient of z equals 2. Constant is -3. The third row will be -2, -1. There's no z term, so put 0. And the constant is 4. So this is the augmented matrix. Of course, the coefficient matrix is only the coefficients of x, y, z. Okay. Then what is the order pair of this augmented matrix? Okay, the order is 1, 2, 3, 3 rows by how many columns? 1, 2, 3, 4. So 3 by 4. How about the coefficient matrix? 3 rows. So there will be 3 by 1, 2, 3 columns, 3 by 3. Okay, so in this case, each column is, the first column is the coefficient of x. The second column, the numbers in the second column in this matrix is the coefficient of what? Y. Good. Okay, the numbers on the third column is the coefficient of, yes, you are right, z. And the last one are the constant of each equation. This represents equation. The columns equation represents the equal sign. Okay, then let's write a matrix in system of equations. Okay, if we want to write this matrix in system of equations, okay, we know the numbers are coefficients, so let's use curly bracket to represent system of equations. The first column, the numbers in the first columns are the coefficient of x. The second columns are coefficient of y. And equals, these are the constants. So the first equation, the first row will give you the first equation. So 3x minus 5y equals 4. And the second row is a second equation. So negative x plus 2y is equal to 0. So this is the system of two equations. Okay, let's try another one. Convert this matrix into system of equations. So x plus 3y equals 2 and 0. The coefficient of 0 is 0. So 0 times x is 0. So we don't have to write x term. Leave it blank. And the coefficient of y is 1. So instead of writing 1y, just write y equals negative 3. Okay, how about the third matrix? Okay, the first equation is 2x plus, okay, y, coefficient of y is 0, so don't write the y term. And then the third one is negative 8z equals 1. Since the second value is 0, we will leave a space for the y term. Okay, the second equation is negative x plus y plus z equals 2. Third equation is 5y minus 5x, 5x minus y plus 7z equals 3. So this is the system of the third matrix, system of equations of the third matrix. Okay, in this example, we will check the definition of row echelon form of a matrix. Okay, let's say here is a system of equations. Okay, earlier the row echelon form of a system of equation is this. Okay, we eliminate this x term from the second equation and eliminate x term and the y term from the third equation. So, as you can see here, the first equation starts with x, second equation starts with y, and third equation starts with z. So we call this row echelon form of system equations. But once we rewrite this in a matrix, from this matrix, just like the system of equations, we will get rid of this negative 1 from the second equation, and number 2 and negative 5 from the third equation. So the final matrix must have 1 in the middle as a diagonal, and the left side of this is all zeros. So the 0 in the first equation, for second equation, means the coefficient of x is 0, so there's no x term. And from the third row, there are two zeros. So first one is there's no x term. The second zero is there is no y term. So rewriting the original matrix into this matrix is called row echelon form. Then how do you make the row echelon form of this matrix? The method is exactly the same as solving the system of equations. So let's use these examples to find the solution. So I will use both the system of equations and the matrix. Okay, so the first equation, okay, from this system of equation, we will eliminate negative x from the second equation. So why don't we just use the first equation so that we can add the first equation to the second. Then the first equation will be unchanged. And the second equation, add the first and the second. So 1 plus 2. First equation plus the second equation. Then x is removed. Negative 2y plus 3y is just y. And 2z plus 0 is 2z. 9 plus negative 4 is 5. Okay, so this is the second equation. How about the matrix? For this matrix, okay, why don't we use the first row to eliminate this negative 1. So the first number is 1 in the first row. Okay, 1 is this is 1 and this is negative 1. So why don't we just add first row and the second row? So first row is unchanged. And for the second row, add 1 to the second equation. Then 0. Negative 2 plus 3 is 1. 2 plus 0 is 2. 9 minus 4 is 5. So actually this second row is the coefficients of the second equation. Okay, now for the third row, for third equation, let's get rid of this 2x. So why don't we multiply the first equation by negative 2 and add it to the third equation. So multiplying the first equation by negative 2, then negative 2x plus 2y minus 4z equals negative 18. Add it to the third equation, 2x minus 5y plus z equals 10. Then cancel out the x term. Then y is, okay, this is 4y. 4y, so just negative y. And this is negative 3z equals negative 8. So the second equation is, the third equation is negative y, right? Minus 3z equals negative 8. Okay, how about so the x term in the third equation has been just removed. This was removed, this was removed. Okay, how about the matrix? For the third one, third row, okay, the third row is 2. The x coefficient of the third row is 2. So we will use the first row to get rid of these 2. Then why don't we multiply the first equation by first row by negative 2? So for this one, I will multiply the first row by negative 2. Then that is negative 2, positive 4, negative 4, and 9 is negative 18. Add this row to the third equation. Third row. The third row is this. Then the first column is 0. Then this is negative 1, negative 3, and negative 8. So the third row is 0, negative 1, negative 3, and negative 8. So let's compare the third row and the third equation. The coefficient of x equals 0, coefficient of y is negative 1, coefficient of z equals negative 3, and the constant is negative 8. Still, we have the same. The system and the matrix are the same. Okay, now since we eliminated the x terms, let's eliminate the y term in the third equation, in this third equation. So we have to use the second equation to eliminate this negative y. Okay, the first equation is unchanged. Also, the second equation is unchanged because we will use the second equation to rewrite the third equation. So why don't we add the second equation to the third equation, because the coefficient of y in the second and third are opposite each other. So y minus y is 0. 2 minus 3z is negative z. 5 minus 8 is negative 3. So this is the third equation. Okay, then how about the row? Okay, let's use the matrix. The first one is unchanged. Second row is unchanged because we want to eliminate this negative 1 from the third equation using the second row. Since the numbers are 1 and negative 1, the y coefficients in the second and third are 1 and negative 1, why don't we just add these two rows? So add the second row to the third row and write the result in the third row. So 0 plus 0 is 0. 1 minus 1 is 0. 2 minus 3 is negative 1. 5 minus 8 is negative 3. So look at this third row. The third rows are the coefficients of the third equation. So we are doing okay. And then finally, let's make the third equation starting with z, not negative z. So write the first equation and the second equation. And the third row is multiplied by negative 1, then z equals 3. So this is the row echelon form of the system of equations, because the third row starts with z, second row starts with y, and the first equation starts with x. Okay, how about the matrix? The matrix, the first equation unchanged, second equation, the second row stays the same. And for the third row, I want to make this one 1 because the diagonal is starting with all ones. So multiply the third row. This time multiply third row by negative 1, then 0, 0, 1, colon 3. So this third row represents, okay, the third row, the equation for the third row is, okay, 1 is the coefficient of z, so it will be z equals 3. 1 times z equals z. So the third row gives you the z value. I think in the previous section I explained incorrectly, because if the third row is 1 equals 1, just like this, then this means the equation for this is z equals 3. Okay, so there is a solution. There is solution. Okay, whenever the third row is 0 equals 0, then there are infinitely many solutions. Okay, there are infinitely many solutions. Okay, so we just rewrote the matrix in row echelon form because the diagonal is all 1 and the left side of this diagonal is all zeros. And for the system, the diagonal is x, y, z, and left of this x, y, z has nothing. Okay, then in next example, we will solve system of equations using matrix. In addition to this, let me explain one more thing. Okay, in this case, if the z value, okay, in this case, the third row has z value. So if you rewrite the third equation, third row in an equation, then z equals 3. So we have a z value, so there is a solution. There is a solution. And if the third row is something like 0, colon 3, then this means, okay, 0z equals 3. So, we cannot find any z value because 0 times something is 0, cannot be 3. So in this case, there is no solution. There's no solution. And the third case is 0, colon 0. Then this means the equation for this is 0 times z is equal to 0. So in this case, z can be any real number because 0 times any real number is 0. So in that case, there are infinitely many solutions. So there are also 3 types of solutions in this case. How do we determine whether there's a solution, no solution, or infinitely many solutions? Is this. Rewrite the third row in an equation. So it looks like z equals something, then this one has a solution. And if it looks like 0 times z equals some number, so 0 equals something, then it's a non-zero, then there is no solution. And number 3 is 0 equals 0. 0 equals 0, then this one has infinitely many solutions. Okay, keep in mind this one. Okay, in this example, we will note the definition of Gaussian elimination with back substitution. Okay, so in order to solve the system of equations, okay, first we need to rewrite. Okay, we need to rewrite the augmented matrix of this system of equations. So why don't we rewrite it like this? Rewrite the augmented matrix, which is 2, -3, colon -2, 1, +2, and 13. So write the augmented matrix of this one. And then we will use the elementary row operations. The elementary row operations are the operations that we used to solve, those are the methods that we used for solving system of equations. Okay. And then finally, that the result of the rewriting the augmented matrix will be in row echelon form. Once we got the row echelon form, then rewrite the row echelon form in the system of linear equations so that we can find z value first, and then y value and x value. So that is use the back substitution to find the solution. Okay, so back substitution means the third row is the value of z. So starting from the third row, find the value from the second row, and find the value of x from the first row. So let's try solving the system of equations using matrix. Okay. So this is the matrix. Okay, row 1 and row 2, we can freely interchange rows. Okay, if the row starts with 1, that is the best one because the coefficient of x is 1. So why don't we just interchange these two rows? So it will be 1, 2, 13, 2, -3, and -2. Okay, then from this one, let's make this to 0. Okay, 2 is the x coefficient of the second equation. So I want to eliminate this 2, make it 0 by using the first row. So since the first row starts with 1, why don't we multiply the first row by -2 and add it to the second equation? The second row. So it will be, okay, the first equation is first row is this, and the second row will be, okay, multiply the first row by -2. First row by -2, so -2, -4, -26. And then add this one to the second row. Add it to the second row. Then the result is 0, -7, -18. Okay, so the second row is 0, -7, and am I doing correctly? Okay, -2. Wait a minute. Okay, there is another mistake. Once we multiply the first row by -2, first row by -2, then this is -26. Okay, so -26 minus 2 is -28. Okay, so this is the second row. Alright, so in order to make this row echelon form, we will have to make this one negative one, I mean the positive one. So why don't we divide the second row by negative 7. The first row is this, second row is multiply the second row by negative 7, divide by negative 7, then 1 over divide negative 28 by negative 7, then that equals positive 4. Okay, so we just rewrote the matrix in row echelon form because the diagonal is 1. Then from this we can use the back substitution, which means starting from the bottom row, rewrite the bottom row in an equation. Then this is z equals 4. Okay, 0 is for the this is the coefficient of y, 1 is the coefficient of z. So z equals 4. So we have the z value. And from the first row, okay, this is the second row. Okay, from the first row, the equation of the first row is x plus 2y equals 13. And then we know the z value, so replace y with z. No, I'm sorry, y is z, sorry, this is y. I'm sorry. Okay, this is y, right? The variable y. So y equals 4. Then x plus 2 times 4 equals 13. Then x plus 8 equals 13. X equals minus 8 each side, so negative, so positive 5. So x equals 5 and y equals 4. So the solution is 5 and x is 5, y is 4. So this order pair is the solution to this equation, system of equations. Okay, we will use the same method. This time let's try a system of 3 equations. Okay, in this example 7, let's solve the system of equations. Okay, first rewrite this in matrix. 3, 3, 0, 9, 2, 0, negative 3, 10, 0, 6, 4, and negative 12. Okay, from here, okay, look at the first row. The first row is a multiple of 3, so why don't we just divide the first row by 3 so that we can have 1. Okay, so the first row, let me go to the right. So first row, I will divide the first row by 3, then 1, 1, 0, 3, 2, 0, negative 3, 10, 0, 6, 4, negative 12. Okay, from here, okay, the first row starts with 1. Okay, and then we will remove 2 from the second row using the first row. So the first row is 1, starting with 1, so we can multiply the first row by negative 2 so that we can eliminate this 2 in the second row. So multiply the first row by negative 2 and add it to the second row. So multiply the first row by negative 2, then negative 2, negative 2, 0, negative 6, and add it to the third row. Add it to the third row. Then this is 0, negative 2, negative 3, and 4. So this will be the second row. So let me write the first row first. And the second row is 0, negative 2, negative 3, and 4. Okay, how did we get the second row? Now multiply the first row by negative 2. So negative 1 times 1 times negative 1. So negative 1 plus 2 is 0. 1 times negative 1 is negative 1 plus 0. Sorry, negative 2, sorry. Okay, 1 times negative 2 is negative 2. So negative 2 plus 0 is negative 2. 0 times negative 2 is 0. and then negative 3 is minus 3. And 3 times negative 2 is negative 6. Negative 6 plus 10 is 4. Okay, how about the third row? The third row starts with 0, so the coefficient of x is 0, so we don't have to do anything. Just write the third row like this. So this system of this matrix has zeros, in the coefficient of x are zeros in the second and the third row. All right, and next is we're gonna make this 6 0 using the second row. Using the second row, make this one 0. Okay, how do we make it 0? Okay, first let's rewrite first row and the second row. Okay, first row unchanged, second row is 0, negative 2, negative 3, and 4. The third row, okay, in order to write the third row, okay, why don't we multiply the second row by 3? So negative 2 times 3 is 6. So when we add 6 to the third row, that becomes 0. So multiply the second row by 3 and add it to the third row. So multiply the second by 3, so negative 6, negative 9, 12, and the third row is, okay, the first one is 0, right? 0. Okay, the third row is 6, 4, negative 12. And add these two rows, then 0, 0, negative 5, 0. Okay, so this is the third row. So write the third row, 0, 0, negative 5, colon 0. So we have a matrix here, and in order to make this augmented matrix, okay, first this negative 2 has to be 1. It has to be 1. So why don't we multiply the second row by negative 2? Okay, this was negative 2, right? So why don't we multiply the second row by negative 2? Okay, the first row is unchanged. The second row, in order to make this negative 1 and positive 1, we have to multiply the second row by, actually divide the second row by negative 2. So negative 2 divided by negative 2 is 1. Negative 3 divided by negative 2 is 3 over 2. And 4 divided by negative 2 is positive 2. Sorry, negative 2. Okay, how about the third row? Okay, third row, we will make this one 1. So why don't we divide the third row by negative 5? So 0 is 0. 0 divided by negative 5 is still 0. Negative 5 divided by negative 5 is 1. And 0 divided by negative 5 is 0. So finally, we have row matrix in row echelon form. So the diagonal is 1, 1, 1. Okay, then from here, let's find the solution. Okay, so the third row, use the back substitution, right? Back substitution. So from the third row, the equation for the third row is z is equal to 0. Okay, this means the z value is 0. Okay, let's use the second method to find the y value. The second row, okay, the second equation for the second row is y plus 3 over 2 z equals negative 2. And the z value is 0, so y plus 3 over 2 times 0, negative 2, then y equals negative 2. So we found the y value. Okay, and from the first row, let's write the equation. We can find the x value. So the first row, equation for the first row is x plus y equals 3. And y value is negative 2. So x minus 2 equals 3. Then x equals plus 2 each side. Then x equals 5. So we found the values of x, y, z. So the order triple is 5, -2, and 0. Okay, this is the solution of the system of equations. Okay. Okay, this is an exercise number 35 on page 200. Okay, this is a case of no solution. So the system of this linear equation has no solution. Okay, let's use the matrix to solve the system. Okay, so let's write the matrix first. 1, 1, -5, 3, 1, 0, -2, 1, 2, -1, -1, and 0. Okay, the first row is starting with 1, so let's use this. We don't have to interchange the rows. So use the first row to eliminate 1 from the second row. So why don't we multiply? Okay, the first row stays the same. It stays the same. We don't have to change the first row. Okay, for the second row, okay, why don't we multiply the first row by -1? Okay, multiply the first row by -1. So multiply the first row by -1 and add it to the second row. So -1. Okay, let me write below this. Okay, multiply the first row by -1. So -1, -1, +y, 5, and -3. And write the second row so that we can add these two rows. Then this is 0, -1, 3, and -2. Okay, so this is the second row. The second row is 0, -1, 3, and -2. Okay, so we have just rewrote the second row starting with zeros, starting with 0 for the x coefficient. Okay, how about the third row? Okay, also we will use the first row to remove the x coefficient 2. So in this case, why don't we multiply? Okay, so the third row is multiply the first row by -2 this time, and then add it to the third row. Okay, so multiply the first row by -2. Okay, multiply the first row by -2. Then -2, -2, +10, -6. Okay, and the third row, write the third row so that we can add these two rows. Then 0, -3, 9, and -6. So this is the third row. So the coefficient of x is 0, -3, 9, and -6. Okay, so we just rewrote the first matrix by making the x coefficients of the second and third row zeros. Okay, from here, okay, now use the second row. This time I will use the second row to make -3, 0, which is the y coefficients of the third row. So okay, let me write the first row and the second row. 0, -1, 3, and -2. Okay, the third row, okay, for the third row, we will multiply. Okay, multiply the second row by -3. So the coefficient, this is -3. So why don't we make this -1 to be 3, so that when we add, the sum will be 0. So multiply the second equation by -3. So multiply the second equation by -3. That is 0. And what is the number for this? I was kind of, okay, this was -1, right? Okay, let me write this one. -1. So -1 times -3 is +3. 3 times -3 is -9. -2 times -3 is positive 6. And write the third row, 0, negative 3, 9, and negative 6. The sum is, okay, zeros, okay, when we add these two rows, it's 0, colon 0. 0, colon 0. Wait a minute. Okay, this one looks like there are infinitely many solutions. Okay, 0, 0. So the third row is 0. Third row is just this one. So we rewrote the third row like this. And from this one, the third row is, what's the equation of the third row is 0 times z equals 0. So that in this case, z can be any real number because 0 times something is 0. So this is always true. So 0 equals 0 is always true, and z value can be any real number. So in this case, there are infinitely many solutions. There are infinitely many solutions because the third row, equation of the third row is 0 times z equals 0, and z can be any real number. So this is an example that has infinitely many solutions, not no solution, I'm sorry. This gotta be this example is infinitely many solution case. Infinitely many solution case, if our calculation is correct. Okay, let me double check. Right, our calculation is correct, so this is the case that the system has infinitely many solutions. Then, what is the type of the solution? Okay, if there are infinitely many solutions, then what's the type of variable x, y, and z? So since z can be any real number, why don't we let the z value is a? Then we can find the x or the y value from the second row and the x value from the first row. Okay, the matrix that we have is, this is not in row echelon form because this is -1, but still it's okay. When we find the solution, still this one is okay. So since z value equals a, okay, let's go from the third equation. Okay, from the second equation, from the second row, what the equation is -y plus 3z equals -2. Since the z value is a, replace z with a, then 3a equals -2. Then -y is equal to -3a minus 2. Divide each side by negative or multiply by negative. Then y is 3a plus 2. So the format of the y coordinate is 3a plus 2. So why don't we write the solution over here? There are infinitely many solutions, and the type of x and y z values are, okay, if the z equals a, then y looks like 3a plus 2. And okay, from the first equation, we can find the x value in terms of a. So the equation of the first row is x plus y minus 5z is equal to 3. Then x plus, okay, y is 3a plus 2. And z equals a. So minus 5 times a is equal to 3. Combine the like terms. So x minus 2a plus 2 is equals 3. Then x equals, okay, move negative 2a to the other side and 2a. And minus 2 each side. Minus 2 each side. Then plus 1. So 2a plus 1 is the expression for the x value. So the x value is 2a plus 1. Okay, so this is the order triple that represent infinitely many solutions for the system of equations. Why infinitely many solutions? Because the third equation is 0 times z equals 3. 0 times z equals 0. So z can be any real number. There are so many z values. So plug in a z value, then you have one order triple, and try another z value, then you have another order triple as a solution. So there are infinite many solutions, and this is the order pair that represents the solutions.